Okay, so section 5.4 is talking about medians and altitudes, since we've already talked about perpendicular bisectors and angle bisectors. So the median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So you're going to see it going from one of the vertices, go to the opposite side, and see the tick marks to show that this is going to be the midpoint. So what you can do is you can use the concurrency of the medians in order to find certain lengths of lines. So this theorem says the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint. So if you have this line, DC is 2/3 of the entire line. That's what it's trying to say. Excuse me. You can also say the same thing about this line. EC is 2/3 of the entire line, and same thing for this direction. FC is 2/3 of FH. So the next thing is a vocab saying that the point of concurrency of the medians is called the centroid. So right here, where these intersect, that would be called the centroid of that triangle. That centroid is also called the center of gravity because it's the point where the triangular shape will balance. And the centroid is always going to be inside the triangle. So the first thing we're going to do is just practice finding lengths using that theorem. So here it says in the diagram that XA is 8 and it wants me to find the length of B. So one way you can tack it is you can just set up an equation. XA has to be 2/3 of the entire length. If I know that XA is 8, then I would just plug in 8 for XA and then solve for what XB has to be. So then in my calculator, all I'd have to do is just divide 8 by 2/3 and I would get my answer, which is 12. Another way, which is how some did it last year in their head, was that if this length is 2/3, then that means that I'm going to split this into thirds all the way across. So 8 would have to be split in half, and that means that this third is a 4, this third is 4, and this third is 4. So then I can add those all up and figure out that it's also 12. So it's kind of your choice on how you want to do it. Those that did it in their head are very number sense savvy, which means that this really makes sense in terms of splitting 8 in half because it's 2/3, and then since it's thirds you can add them all up. Just pay attention to what the question is asking, because sometimes they're asking for the full length, sometimes they're asking for the shorter length. Okay, you're going to pause the video and try the got it question. So in the got it questions, it tells you that ZA is 9 and that you have to find the length of ZC. So you could set up an equation where you had 9 in for ZA, 2/3 equaling ZC, and then you could just divide 9 by 2/3 on your calculator and it would give you the answer, which is 13.5. The other way, if you did it in your head, you would need to split 9 in half, which is 4.5, and that means that every third along that way would be a length of 4.5. So then I would have to add 4.5 3 times, and that's another way to get that 13.5. Okay, the second question asks what's the ratio from ZA and AC. Well, your ratio is ZA is 2/3 of the line, whereas AC is just 1/3 of the line. So that means that ZA is going to be twice as long as what AC is. This question is not quite as important to me if you're not understanding it. The main idea is just making sure you know that the bigger portion of it should be double the size of what the smaller portion should be. Okay, the next thing is a vocab, which is an altitude. And an altitude is a perpendicular segment that goes from the vertex to the opposite side. So we're going to practice some of our vocab from the pictures to see if we understand what that is. So letter A says, in this triangle, is PR a median, an altitude, or neither? Well, from the picture I see that it goes from the vertex to an extended opposite side and is perpendicular. So the vocab that's always perpendicular is altitude, so that's why it's going to be altitude, because it's perpendicular going to the opposite side. The next question says line QT. Which one is that? Well, it goes from the vertex to the opposite side, but I see these tick marks which indicate a midpoint. So that means that QT has to be a median since I see the tick marks that it's connecting to. Alright, you're going to pause the video and try the got it question. So in the got it questions, finding which one those are. AD goes from the vertex to the opposite sides and has tick marks, so it indicates a midpoint, so that's going to be a median. EG does not go from a vertex at all, so that's going to be neither. CF goes from the vertex to the opposite side and is perpendicular, so that's going to make it become an altitude. So that question is just practicing that vocab, making sure you can identify what they are. Alright, next part. There's a theorem that says the lines that contain the altitudes of a triangle are concurrent. And all that is saying is that your altitudes will intersect. That's all it's saying. So then down here at the bottom, something you want to highlight is that what an orthocenter is. And an orthocenter is where your altitudes are going to intersect at. So notice that the orthocenter is inside an acute or an obtuse triangle, but it will lie on the triangle if it's right triangle. Okay, so our next task then is we're actually going to practice finding that orthocenter just like we did earlier with a circumcenter. Okay, so you have a triangle that has these vertices, and you have to find what the orthocenter is. So the first thing I did was I went ahead and plotted those vertices on my triangle. Okay? Now remember, an orthocenter means I'm trying to find the intersection of the altitudes. Okay? So altitudes means I'm going from the vertex to the opposite side and is perpendicular. So the first thing I did is I looked at my triangle and I found that line AC is horizontal. So it would be really easy to find a line that's perpendicular to it because a line perpendicular would make it become vertical. So if I'm going to be an altitude coming from B, I would just go straight down from it and it would be x equals 2. So I just went ahead and drew in that line. So the first thing I would always look for are there any horizontal or vertical lines, and if there are, start at the opposite vertex and just go the opposite direction. So since this was horizontal, I'm going to make this a vertical line so that it's perpendicular right there. Okay? Now the other two lines are not horizontal or vertical, so this is where it becomes a little bit more challenging. So what you're going to do is you're just going to pick one of them, and I picked this line. And if I'm going to make the altitude that goes to it, it's got to be perpendicular. So what I did was I found the slope of this line. So I counted the rise and the run. So I went 1, 2, 3, 4, 1, 2, 3, 4. So my slope was -4/4, which means the slope of line BC is -1. Okay? Remember when I was doing perpendicular, and when I was doing perpendicular, my slopes are opposite reciprocals. So if I'm trying to make a line that's perpendicular to this, I'm going to have to do the opposite and reciprocal of it. So the opposite of -1 would be +1, and then the reciprocal of that means I'm going to flip it, which in this case still just stays as 1. So what you're going to do is you're going to start at the vertex that's opposite of it and just count up 1 and over 1 because that's what my slope was. So up 1 over 1, up 1 over 1. And then remember, we're trying to find the orthocenter, which is the intersection of the altitudes. So I just drew in 2 altitudes. So my intersection point is where they cross at. So that's going to be at 1, 2, 1, 2, 3, 4. So that's why my answer is at 2, 4. Now the book goes through and has to try and find the equations of the stuff. You don't need to do all of that. all you need to do is find the lines that are perpendicular. So the easy ones are the ones that are horizontal or vertical, because then you can just go the other direction. The ones that are a little bit more difficult are the ones that are slanted. So remember, find your slope. You have to do opposite and reciprocal of it because you're going to do perpendicular, and then go from the opposite vertex and use your slope to find that line. Alright, you're going to do the got it question. So in the got it question, I went ahead and graphed my vertices. Since I have a right triangle, I used the two legs of the right triangle to find my altitudes. So if I was going from F straight down to this side, this line that I just drew would be the altitude of this one. Same thing for E. I can go straight down and I'm crossing through this opposite side, and now I have that altitude involving E. So then where those two intersect at is this point there. So then I would just count. So from the origin I would count over 1 and up 2, so my answer would be at 1, 2. So I gave you two different examples. You may want more practice on this, which is perfectly fine, but I want you to see that if you have obtuse or acute triangles, the orthocenter is inside, but if it's a right triangle, it's going to lie on top of one of those sides. So vocab: medians, altitudes, orthocenters, and a centroid.